two elements of 4 and 5D transition metals. They are located just below copper and belong to group 11, so it's natural to talk about them after copper. Electron configuration for both of them is 5s1, 4d10, and 6s1, 5d10. But it will be 4f14 subshell present in gold, making some difference for properties. So some properties of gold will be similar to mercury, thallium, lead, and bismuth that belong to the same configuration. Both of them will have stable oxidation number of +1. Oxidation numbers 2 and 3 are possible for silver, but very unusual. Oxidation number. Silver was one of the metals of antiquity that were known to prehistoric humans and whose discovery is lost in history. Silver is more reactive than gold. That means that natural silver exists and can be mined. Just photo of silver crystals from Cliff Mine. But supplies of natural silver much more limited than those of very inert gold. Historically, silver was more expensive than gold, then almost as expensive as gold, and only very recently became almost 100th cheaper. A very common form of silver are different sulfides. If pure silver sulfide, it will be black rock, but it can be admixtured to many other sulfides, say of copper, of iron, and other metals. Mining of silver sulfide ore was known for thousands of years. An interesting example is Czechish town of Yachimov. The valley in which is it, you can see the mine here, is Joachimsthal. Tal means valley. So the coin they minted from local silver was Joachimsthaler, or simply Thaler. That's it, from year 1525. This was silver coin standard for centuries, and then corrupted through Spanish. It became dollar. American dollar takes name from this place, this silver mine. Silver is extremely ductile. You can make a wire literally 1 atom wide. You can make very thin layers of silver. Electric conductivity of silver is the greatest of all metals. The primitive explanation of very high conductivity of elements of group 11 is that one electron is located on s orbital above d10 shell, making free movement of these electrons possible. Silver does not react with air, doesn't make stable oxide that easily, but reacts with sulfur and different sulfides present in air to make black silver sulfide. So silver objects usually become blackish with time. Metal silver does not react with S2 inert, but it reacts with concentrated nitric acid, that is oxidizer, or with diluted nitric acid, same as copper, to make silver, iron, NO2, and water. Same with concentrated sulfuric acid, silver, iron, SO2, and water. Interesting reaction is reaction of metal silver with cyanide in presence of oxygen or other oxidizers to make very stable dicyanoargentate. So you have two cyanides on opposite sides of silver ion. This is fantastically stable complex, and it shifts equilibrium to the right, making feasible dissolving of silver. It has practical use of treating ores of silver. Most common salt is silver nitrate, colorless, beautiful crystals. Its starting point for making silver solution, many of other silver compound, and it has medical use as antiseptic. It decomposes at high temperature, yielding silver metal, oxygen, and NO2 gas. Silver makes insoluble chlorides, white AgCl, cream Ag bromide, GBr, and yellowish AgY, having slightly different crystal cell. All of them are cubic. Silver chloride can be dissolved in very diluted ammonia to make Diamine Complex. For bromide, you need to take more concentrated ammonia. Very concentrated can dissolve even iodide, which is least soluble. Silver cyanide, AgCN, is insoluble in water, but if you add stoichiometric excess, one more cyanide, you will have dicyano complex that has very high solubility. This is how you can dissolve any of halogenides. Alternatively, to dissolve halogenides, you can use sodium thiosulfate, which reacts with silver through its sulfur atoms and making very stable complex AgS2O3 minus. It can take 2 thiosulfates, 3 thiosulfates, all of them will be stable complexes. Thiocyanate makes insoluble silver thiocyanate like bromide chloride. Very famous use during the last 100 years was silver photography. It's still very nice way to get high quality images. Usually 35mm film, for example, is analog of high quality 20 megapixel image. And with large cameras, you can get up to 2 gigapixel images, which is much more difficult even now to get with image plates or other digital imaging. Briefly, what happens? Just photo paper example. Film has similar section. You have paper substrate, then layer of barium sulfate, which reflects light nicely, and you'll have better image. Then you'll have silver particles in gelatin, very thin layer, and surface coating. So what happens when silver particles, these are microphoto of silver particles, usually it's silver bromide, sometimes a little bit of silver iodide and chloride. when light photon strikes it. Usually there is so-called sensitivity spec, the admixture at which reaction occurs. So when photon strikes, uh, here silver ions are coming to this place, and very small microparticle of metal silver occurs like that. This is so-called latent image. It can be stored on cold for dozens of years. Now, to see the image, you need to develop it. So, in dark, this image is exposed to some reducing agents. Most common is hydroquinone with sodium sulfite to protect from oxidation. Next, reducing agent reduces all silver in this crystal from silver bromide to metal silver. Whatever silver crystallites are left in emulsion are next removed with sodium thiosulfate solution, so-called fixing process. After that, everything is rinsed with water, and you have an image that can stay literally for hundreds of years. Next metal, this group, gold. This is the earliest recorded metal employed by humans. Small amounts of natural gold found in Spanish cave used during late Paleolithic period. That is 40,000 years ago. Uh, Gold often is natural, can be found in nature. Uh, the uses are mostly jewelry, but there are lots of beautiful, interesting uses because gold has very high electric conductivity. It's very resistant to oxidation. It's very nice material for different connectors in electronic. Even more, because it's soft, it actually sticks. These surfaces stick to each other, making conductivity on contact even better. It used for making seals and washers for different devices, keeping in mind that a layer of gold can be made very thin. The price of these items is essentially the same if they would be made of other metal. Another example of beautiful coating is mirrors for infrared area that will stay intact for very long time. Gold mining uh, is done mainly by chemical means. Of course, you can find a chunk of gold, but that's very improbable. So mainly rock is treated with cyanide in presence of oxygen to make sodium dicyano complex, similar to what you have for silver. So if any silver admixture is present, it will go together. Next, uh, this is treated to remove gold from solution. Enormous amounts of sodium cyanide, which is very toxic, are necessary for this method. Gold cyanidation banned in many countries, in many of American states, but not all. There were several major accidents related to cyanides. Gold production is not very high. We are talking about hundreds of tons per year. Gold is insoluble in any pure acid, but it can be dissolved in nitric acid in presence of chloride. So the resulting compound is AuCl3, which in turn reacts with one more chloride to make AuCl4 minus an ion. Uh, this reaction is reversible. You can make Au2Cl6, which is same as AuCl3 in solution, and this is a solid dimer. It's bright yellow, orange. So again, you need a mixture of nitric and hydrochloric acid to do this whole process.